Six Sigma Center Come.
All right, welcome. Today, we're going to crack open a powerful toolkit that's all about making sense of those super complex business processes. We're going to explore 7 key modules that work together like a high-tech diagnostic system, helping you find and fix those sneaky problems you might not even know you have. I mean, that's the big question, isn't it? It's the core challenge for anyone trying to improve a process. If your system is complex with dozens, maybe hundreds of variables, trying to find the root cause of an issue can feel like you're just fumbling around in the dark. So how do you find that one signal in a sea of noise? And that, my friends, is where this toolkit really shines. The best way to think about it is like a pilot's instrument panel. Each of these modules takes this overwhelming, complex data and just boils it down to a clear, simple indicator, telling you, hey, you're on course, or, uh-oh, turbulence ahead, and crucially, exactly which levers to pull. Okay, so here's our game plan for today. First, we have to build a foundation of data we can actually trust. Then, we'll use that data to find the real problem, prove our fix actually worked, and then, this is the cool part, we're going to shift from just controlling the process to actually predicting what's going to happen next. All right, first things first, the measure phase. This is, and I can't stress this enough, the absolute bedrock of any improvement project. Because if your measurements are off, every single analysis, every decision you make from here on out, it's all based on a flawed reality. It's built on sand. So this is the first hurdle we've got to clear. I mean, can you imagine spending a ton of time and money on a big process change only to find out that the measurements you started with were just wrong? It's a nightmare scenario, but believe me, it happens. So how do we stop that? We avoid that nightmare with 2 key tools. The first is called a gauge R&R analysis. Now, the R&R just stands for repeatability and reproducibility. Basically, it's a checkup for your measurement system. You gotta know if you can trust your ruler, right? Once we know our ruler is good to go, then we use the second tool, distribution analysis, to start understanding the story our data is telling us. And when it comes to that gauge R&R, there's a magic number you're looking for. You want the error from your measurement system to be less than 10% of the total variation in your process. Why? Well, think about it. If that error number creeps up to, say, 30%, that means a third of what you're seeing isn't your actual process. It's just static from your measurement tool. That's why getting under 10% is the gold standard. It tells you, okay, my instruments are good, I can trust what I'm seeing. Okay, so now that we have data we can actually trust, we get to move on to the fun part, the analyze phase. This is where we get to ask the exciting question, so, what's this data really telling us about how things are going? And it all boils down to 2 big questions. 1, is your process stable? Is it behaving predictably day in and day out? And 2, even if it is stable, is it actually good enough to meet what your customers are asking for? To check for that stability, we use a fantastic tool called Statistical Process Control, or SPC for short. The best way to think about an SPC chart is like an EKG for your business process. It tracks the heartbeat, showing you the normal, steady rhythm, and it'll sound the alarm the second something goes haywire. Now, one of the most important jobs of SPC is to help us tell the difference between 2 kinds of variation. First, you've got common cause variation. That's just the background noise, the normal expected ups and downs of a healthy process. But then you have special cause variation. That's the alarm bell. That's a sign that something unusual has happened, and we need to go figure out what it was. Okay, so our process is stable, great, but is it any good? That's the next question. And for that, we turn to process capability analysis. This tool is brilliant because it directly compares the voice of your process, what you're actually producing, with the voice of your customer, what they actually want. It shows you exactly how well you're meeting their needs. And we measure this with a score called CPK. Think of it like a grade for how well your process fits inside the customer's requirements. A CPK of 1.33 is like getting an A. It's the industry gold standard. Hitting that number means you're not just capable, you're excellent. We're talking a defect rate of less than 64 parts per million. That's pretty amazing. All right, we've analyzed the problem. Now it's time to do something about it. Welcome to the improve phase. We've put a change in place, but here's the kicker. How do you know for sure with statistical certainty that your solution was the thing that actually worked? This phase is all about tackling 2 huge challenges. First, we need to get away from just thinking our fix worked and get to a place where we can prove it worked. And second, we don't just want a fix, we want the best fix. How do we find the optimal settings to really make this process sing? To get that proof, we use something called hypothesis testing. This is really the heart and soul of making decisions with data. It lets us look at the before data and the after data and use math to say, yep, that improvement is real, or nope, that was probably just random luck. No more guesswork. You know, a lot of people get hung up on picking the right statistical test, but a good module just guides you right to it. It's simple. Are you comparing just two things, like before and after? Cool. Use a t-test. Comparing 3 or more things, like maybe 3 different machine settings. Then you'll want something called an ANOVA. It's all about matching the right tool for the job. But what about finding the absolute best settings? For that, we bring out the big guns, design of experiments, or DOE. The old school way is to change one thing at a time, which takes forever and often misses the best solution. DOE is like a super smart way of testing everything at once. It's a total game changer for finding that perfect combination of settings in a fraction of the time. And that brings us to our final phase, control. But we're not just going to talk about holding on to the improvements we made. No. In today's world, control means more than that. It's about looking forward and predicting what's just around the corner. And this is a really important mental shift. See, a standard control chart is reactive. It tells you after a problem has already happened. But what if? What if your dashboard could warn you that a problem is coming, giving you a chance to dodge it completely? Well, that is the incredible power of predictive modeling. It takes all your past process data, feeds it into some smart machine learning algorithms, and builds a forecast. It's basically like being a weather forecaster for your own process. This lets you go from being a firefighter, always putting out fires, to being a fire marshal, preventing them from ever starting in the first place. So let's just recap that whole journal. You can see it's a really logical flow, right? We start with the absolute foundation, getting data you can trust. Then we figure out what that data is telling us. We prove our solutions actually work. And finally, we level up to not just control the present, but to predict the future. So in the end, this toolkit isn't just about putting out today's fires. It's about building processes that are so smart and so robust that they can see tomorrow's challenges coming a mile away. And that leaves us with one last thought to chew on. Once you've truly mastered control, are you ready to start predicting?
6 Sigma in the dark,